Hello, welcome to Physics with Chris. And in today's lesson, we are looking at dimension of physical quantities. Dimension of physical quantities using velocity and acceleration as our example. Using velocity and acceleration as our example. You will recall that dimensioning of physical quantities means how derived quantities are related to fundamental quantities. How derived quantities are related to fundamental quantities, or how derived units are related to fundamental units. And don't forget that in dimensioning, these three basic fundamental units must be involved. These three basic fundamental units must be involved. You have the first one, you have mass, which is represented with m. You have time, which is t. Then you have length, or distance, or displacement, which is represented with L. Oftentimes, in all dimension questions, these three basic fundamental quantities, 1, 2, or 3 of them may be involved. Take for example, let's look at velocity. You have the first one, velocity. And recall that velocity is given by displacement over time. Velocity is displacement over time. Then velocity v is equal to what is displacement? That distance moved in a specific direction. Displacement means distance moved in a specific direction, which is L. Distance is represented with L. Then time with t. Then if I simplify this one further, I can write this one as v is equal to L times 1 over t. V, that's velocity, is equal to L times 1 over t. And 1 over t in indices is the same thing as t raised to power minus 1. So I can have v is equal to L times t raised to power minus 1. Then if I multiply together, my v will be equal to LT raised to power minus 1. So this LT raised to power minus 1 is the dimension of velocity. So that's what we refer to as dimensioning of physical quantities. Let's look at acceleration. Acceleration is equal to velocity over time. Acceleration is velocity over time. If acceleration is velocity over time, it means that acceleration A is equal to velocity. Let's assume I put the value of velocity, which is this our velocity. I will have LT raised to power minus 1, everything over t again. If I write this one in indices, I can have acceleration is equal to LT raised to power minus 1 multiplied by 1 over t. So LT raised to power minus 1 times 1 over t. So my acceleration will be LT raised to power minus 1 times t raised to power minus 1. This one can be written as t raised to power minus 1. Then in indices, I will take one of the t now, then add the power. So my A will be L. Take one of these t now, it will be t raised to power minus 1 plus minus 1. I'm taking one of the base now and adding the power. So my A will be equal to LT raised to power minus 1 plus times minus is minus. So my A will be LT raised to power minus 2. So this LT raised to power minus 2 is the dimension of acceleration. So these are examples of dimension of physical quantities. Stay tuned to this channel, which is Physics with Chris. Subscribe to the channel and turn on the notification button so that you can get our latest video, because more examples are still coming on dimension of physical quantity. Bye bye.